I'm a huge fan of the Great British Baking Show. I think I got addicted to it during the pandemic, so it actually helped give me the confidence to try more complicated hydrogels and procedures because I gained a lot of inspiration from how cooking processes can turn into art and using that in science to create more like artistic 3D replications of tissues. My name is Allison Reno, and I'm a postdoc in the pediatrics department at the Medical University of South Carolina. I am a material scientist, so not every lab has one of those. We are hoping to achieve much better, much more accurate 3D modeling in cancer and really push labs to start using the 3D. Sometimes we get slightly more accurate results of what a drug will be like in a human by incorporating some of these 3D models into experiments. The Langdon Lab actually reached out to me when I basically told MUSC, the pediatrics department, that I was graduating and that did they have any 3D culture projects that had a big need. They said, yes, we have no genetic mouse model for sarcomas. So we are unable to very accurately model these cancers. And so because of that, there's been no drug development in over 40 years. So we're still using the same very basic chemotherapies from really the 70s on these kids. So traditionally, since the 60s, when you have your first biomolecular experiments, we were culturing just flat layer of cells with no material around them, no extracellular matrix, which is basically the structure that our cells live in. So I like to think of it as like the Ravenel Bridge and we're the cars. So basically you are having the cars, but not the bridge. So you're not getting the real mechanical structure. So now a lot of 3D culture work is we are adding that structure in. We are creating a gel that mimics the real tissue mechanically and then adding the cells in, and then we have a more complete tissue model. Because a tumor is not just tumor cells, it has other cells. So for example, they have a lot of episodes on Great British Baking Show of like art in jello or like gelatin art, and that's extremely similar to hydrogels because we are basically injecting cells and things into a gelatin or gelatin-like material. So the same way that a chef or a pastry artist like injects a flour dye into a gelatin, we are injecting cells into a fake tissue gel. So there's no true genetic mouse model specifically for Ewing sarcoma, which is one of the sarcomas with the least progress in over 40 years. So to make progress in these, we need better models. We need models that we can actually screen how the drug works in the bone microenvironment, seeing, you know, does this harm the bone density of a child in addition to the tumor? That's a really important thing because we don't want to treat a child and then they have lifelong osteoporosis. So models like this give us the ability to really fine-tune a drug and target it specifically to the tumor.